Today, we are going to talk about Knuth-Morris-Pratt Algorithm. It's a string matching algorithm which searches for a currency of a word P within a large text string T. KMP needs to build a prefix table based on P first, and then do the match. The prefix table helps us to shift the pattern faster without missing any matches. When a mismatch occurs at index j, the pattern is shifted by a distance according to the prefix table. Here we got an example. As we can see, we got a word P, XYY, XY, XX, which we need to find where it is in the text string T. Like I said, we need to build a prefix table by P first. Following the code here, let M equal to the length of P, which is 7 here, and pi1 is 0. I starts from 0. Then we get a for loop. For j is 2, up to m, step 1. We got I is 0, so this is false. Then we can see p1 is x, but p2 is y, so it's false again. Then we have pi2 is 0, so for loop again. J becomes 3 and I is still 0. Then we got p1 is x and p3 is y, so false again. Then pi3 is 0. For loop again. Now j becomes 4 and I is still 0. Then we see p1 is x and p4 is also x, so it's true, and I becomes 1 now. Then we got pi4 is 1. For loop again, and j becomes 5. Now we have I is 1, but p2 and p5 are both y, so false again. But this is true, so we have I is 2 now, and pi5 is 2. For loop again, j is 6 now, I is 2. Then we can see p3 is y, and p6 is x, so this is true. Then I becomes pi2, which is 0. Then while loop again. Now I is 0 again. Then we see p1 is x, and p6 is also x, so that's true, and I becomes 1. Then pi6 is 1. For loop again. J is now 7, and I is 1. Then we have p2 is y, and p7 is x, so this is true. Then I become pi1, 0. While loop again. We have I 0, so this is false. We see p1 is x, and p7 is also x, so this is true. I becomes 1, and pi7 is 1. So we have finished prefix table. Then we need to move on to the second part. At the beginning, n equals to length of t, and m equals to length of p. I starts from 0. Then we get a for loop. For j is 1 up to n step 1. Here we have I is 0, so this is false. Then we can see p1 is x, and t1 is also x. So I becomes 2, which is not m. For loop again. J becomes 2, and I is 1 now, but p2 is y, and t2 is also y. So I becomes 3, which is not m. For loop again. J becomes 3, and I is 2 now. We see p3 is y, and t3 is x. So I becomes pi2, 0. While loop again. I is 0. Then we see p1 is x, and t3 is x. So I becomes 1, not m. For loop again. J becomes 4, and I is 1 now. Then we see p2 is y, and t4 is also y. So I becomes 2, which is not m. For loop again. J becomes 5 now, and I is 2. We see that p3 is y, and t5 is also y. Then I becomes 3, not enough to m. For loop again. J becomes 6 now, and I is 3. We see p4 is x, and t6 is also x. So I becomes 4, not m. For loop again. j becomes 7 now, and I is 4. We see p5 is y, and t7 is also y, so I becomes 5 now, not m. For loop again, j becomes 8, and I is 5. We see p6 is x, and t8 is also x, so I becomes 6 now, not m. For loop again, j becomes 9 now, and I is 6. We see p7 is x, and t9 is y, so this is true now. Then I becomes pi6, 1. Then while loop again, I is 1 now, we see p2 is y, and t9 is also y, so I becomes 2, not m. For loop again, j becomes 10 now, and I is 2. We see p3 is y, and t10 is also y, so I becomes 3, not m. For loop again, j becomes 11 now, and I is 3. We see p4 is x, and t11 is also x, so I becomes 4. For loop again, j becomes 12 now, and I is 4. We see p5 is y, and t12 is x, so this is true. Then I will be pi4, 1. While loop again, now I is 1, p2 is y, and I12 is x, so it's true. Then I will be pi1, 0. While loop again, I is 0 now. Then we see p1 is x, and j12 is also x, so I becomes 1, not m. For loop again, j becomes 13 now, and I is 1. We see p2 is y, and j13 is also y, so I becomes 2, not m. For loop again, j becomes 14 now, and I is 2. We see p3 is y, and t14 is x, so it's true. Then I becomes pi2, 0. While loop again, I is 0 now. We see p1 is x, and t14 is also x, so I becomes 1, not m. For loop again, j becomes 15 now, and I is 1. We see p2 is y, and t15 is also y, so I becomes 2, not m. For loop again, j becomes 16 now, and I is 2. We see p3 is y, and t16 is x, so this is true. Then I will be pi2, 0. While loop again. If we keep doing like this, finally we will get I equal to 7 when j is 22. So we output j minus m, which is 15. Then we will know the same string as p will start from the 16th in t. Here is about the time complexity. By the way, in the previous example, Navi method does 41 comparison, and KMP does only 28 comparison. So we should know KMP works better for small range of characters to deal with repetitive patterns. Thank you.